Welcome, everyone. Can you hear me? Hopefully you can. And thank you very much for joining today's session. We are so excited to have so many of you here. We're here in our webinar today with our buddies from Digital Velocity team at CDW. And we're here to talk to you about some hot topics with Kubernetes and GitOps, which have been around for a number of years. But for those of you coming up to speed, we'll show you how to bring that all together to accelerate the delivery of applications and deploy and manage Kubernetes infrastructure wherever this needs to be. Let's do a quick round of introductions. My name is Jesse Benoit, and I'm a solutions architect at Spectro Cloud. Now, I spend my days working with customers and architects like my fellow panelists to assist our customers with technologies that help them speed up application delivery. We architect solutions to deploy and manage Kubernetes clusters securely and with required enterprise integrations, infrastructure, and services, all at scale. Joining me to discuss some of these challenges and solutions we see are two seasoned industry veterans, Kyle Jepson and Neil Wiley. Kyle and Neil, can you please introduce yourself?
Yeah, thank you, Jesse. Hi, everyone. I'm Kyle Jepson. I'm a strategic architect within our Digital Velocity practice at CDW. Means that I'm part of our portfolio team, and I get to work with folks like Jesse and some of our other partners to be able to build solutions that help customers to solve some of their most complex challenges. I hold a CKA. I'm based out of Las Vegas. Really happy to be here today. I hope you enjoyed the conversation. Thank you.
Thank you very much. Neil?
Yeah, of course. Hi, everyone. I'm Neil. I work with Kyle and Jesse. I'm the chief architect, so I look at what's in the market. I look at what the industry is doing and try to make sure that we at CDW are pairing with the best in the market, like Spectro, to really fit the needs for what's going on in the market today. Thanks, Jesse.
Great. Thank you very much both for joining us. Maybe you could tell us quickly a little bit, where'd you take those pictures?
Oh, yeah. So it was a race just outside of Austin, Texas. So I'm based in Austin. It was a gravel race just outside of Austin, Texas. So we've got a great riding scene here.
All right. Kyle, where'd that picture come from?
That's just a CDW headshot from back in the day out of the office in Chandler, Arizona. So.
All right. I took that meeting right. My picture was right in line after about 15 of my colleagues. We had a meeting out in Miami. So I'm pretty excited. That was my first picture at Spectro Cloud. So interesting to see where we got all those pictures. So welcome. I look forward to diving with both of you. But a few details we'd like to share first. Here on the screen, I should be sharing my agenda for today. Can everybody see that?
Looks good.
Oh, great. After we begin, please feel free to type any questions you have in the chat window as we go. We'll hit them during the presentation. Any questions before we start?
None so far.
All right, let's dive in. So today in this presentation, we're going to talk about three different kinds of personas that we see. And we're going to heavily focus on the two personas on the left, app developers and operations. All the while, those two collaborate together with the security team to deliver secure and fast applications. And here's what they do. You know, we have the developers that are spend a lot of their time coming in the morning, writing and fixing code, making sure that new integrations are working together, and they're focused on the inner loop. At some point in time, that they'll have to move and take the application and move it to the outer loop. With today's technologies, we're going to talk about, we're going to heavily focus on the inner loop, but also talk about best practices as you get your application out to the outer loop as well. Okay, so we see ops and devs teams that want to work together these loops together and the challenges they must overcome. For example, we can deploy applications via VM, real metal, or using containers. We can deploy on premises, in the cloud, or potentially a combination of all that with managed services. While we do this, we must foster collaboration and speed, doing things securely and repeatedly, in line with enterprise standards and promises. Now, this interaction is sophisticated. Different environments, different clouds, different tools, different versions, best practices, etc. Now, Kyle, Neil, myself, after performing discovery, documenting, architecting, designing Kubernetes solutions as part of our work, we'd like to share some of those challenges we see. And I boil them down to a few things. One, Kubernetes is complex. very complex. Developers within their inner loop, they want a simple Kubernetes environment to deploy and test their applications. Now, a typical production environment is very complex to deploy and maintain. Over time, multiple Kubernetes environments get expensive. Now, Neil and Kyle, can you share some of your interactions? For example, when I meet with my customers, one of the things that I hear is, hey, you know, our developers are spending months or weeks learning Kubernetes, and our management and our team want them to focus on application and delivery. So, you know, those are some of the challenges that are really close and near and dear to my heart. But please do. What do you guys see in the field?
Yeah, I mean, I love the points that you have up here. A lot of the time, Kubernetes is just a little bit on the complex side, right? What we see a lot of the time is that automation helps us to be able to de-risk changes, to keep things repeatable, and to help organizations to be able to democratize access to these kinds of complex technologies. That last one, Terraform is law. We see a lot of organizations that are leveraging tools like Terraform for being able to provision, manage, deploy applications and infrastructure together. And one of those common patterns that we see is GitOps. GitOps often starts, though, when there's already a Kubernetes API that you can hit, because Kubernetes is by itself declarative. And we'll talk a little bit about GitOps, and maybe that's a good segue into backing up and talking a little bit about the history of GitOps and how we got here. But yeah, ultimately, you know, that automation component and what we're going to look at today is that the GitOps process and automation often starts with, hey, we already have a cluster. Well, we're going to look at how can we back that up and look at using the GitOps patterns that developers are already using for being able to create and provision those clusters. So maybe we can go to the next couple of slides here. So for those that aren't as familiar with GitOps and kind of where it came from, 2017, Weaveworks had a major outage. They described this incident that they had where a developer pushed a change into production that took the whole system down. And they were able to recover that whole system in about 40 minutes because the entire configuration and all of the declared state or desired state of the system was all defined in Git and in their Git repo. So they were able to bring that all online very quickly. And in their postmortem, they said, hey, this is actually a really good idea. So they coined the term GitOps. And over time now, we see GitOps as a part of the Open GitOps project, which is a CNCF sandbox project that's a part of the GitOps working group. And they are responsible for kind of defining what those principles of GitOps are. And if you go to their website and you take a look at what they're saying that individuals and organizations are going to get out of leveraging GitOps-based patterns, they're going to get increased developer and operational productivity, enhanced developer experience, improved stability, higher reliability, consistency and standardization, stronger security guarantees. And those all sound like great things. So we should probably be looking at incorporating that kind of stuff into infrastructure patterns as well. And so Spectro Cloud has given us that ability with Palette and the Terraform provider to have declarative infrastructure. And so those core GitOps principles that the Open GitOps project has defined are, you know, the desired state needs to be expressed declaratively. You need to have desired state stored in a way that retains its version history, it's immutable. And then you need to have software agents that can automatically pull from that source, and then a constant reconciliation or continuous reconciliation process between desired state and current state. So with those four things, we're getting into GitOps-based patterns. And a lot of the time that's application-based, but we can also leverage those same kinds of principles for infrastructure provisioning as well. And that makes clusters more ephemeral, and that makes it kind of changes the way that we approach cluster architecture and how quickly we can spin things up and have a place where developers can develop and places where we can deploy applications. Is there anything you guys would add to any of that?
No, I think you absolutely covered it.
Yeah, I'm a big history guy. My undergrad's actually in history, so it's great to hear that story. Thank you very much. And also interesting, I think that we really wanted to share and highlight is that some of these best practices came out of application delivery. Now we're flipping them around and we're using them for infrastructure. So exciting times to use some of these tools, and look forward to diving in with you.
Yeah, absolutely. So if you go to the next one, we could talk a little bit about what we did at CDW to be able to leverage Spectro Cloud and to leverage some other tooling to bring them together to create this kind of services bundle that we're calling the Multi-Cloud GitOps Foundation. And the idea behind this is, again, we're going to use those GitOps-based patterns, and we're going to incorporate GitOps throughout for both application delivery, but also for infrastructure provisioning and for the Kubernetes cluster provisioning across any cloud. So that's hence multi-cloud, but doing GitOps. We want to lay down a foundation to be able to help organizations to quickly operationalize these concepts. So if you go to the next one.
Sure.
So when we approached this, we started with the principles in mind, and we knew, based off of the challenges that you laid out there, Jesse, those are things that we see frequently. So we knew that we needed to have portability. Organizations are using multiple clouds. They want to be able to land clusters in multiple places. So having Spectro Cloud palette there to be able to land clusters in AWS, Azure, GCP, VMware, Metal, Edge, you name it, was really attractive. Having a code-first approach, using GitOps as an extension of DevOps and IAC-based principles, having that repeatability and consistency. Having clusters as ephemeral as possible, being able to destroy and recreate them. Having all of this being as simple to use as possible to reduce pain, reduce toil, and provide consistency between higher and lower environments. And we'll show you today how all of that's possible, but largely what you can see is that we're going to keep everything in a version control system. We're going to have everything declared in Git. We're going to have an infrastructure as code provider that is going to pick up and continuously reconcile state, desired state versus current state. And then we can land that anywhere using the CAPI providers in Spectro Cloud Palette.
That's right. Absolutely anywhere, whether it's at the edge in the data center or in the cloud.
Yeah.
And I could see the benefit of this as well, too, because, different teams, different regions, different geographies, they could point or GUI click their way through some of these deployments or at the command line, all with their own individual tools. And then when the enterprise team comes and takes a look at it, they have all these disparate solutions. So, using one like Terraform is law comment. I like to use that. Using one solution to deploy, to kind of safe rail and guardrail and check on all these installations is important. And I think GitOps really does that for you, both infrastructure and applications.
Yeah, absolutely. If you go to the next one, we can talk through a little bit more of the details here. So in the demo today, and some of what you're going to see, we're going to use GitLab, we're going to use Terraform Cloud. A lot of this is inherently enabled inside of Palette, being able to have things like cluster profiles and cloud accounts and add-on packs that we can define all in code in Terraform, so that we can provision clusters declaratively in those environments that we've defined. So this engagement is all designed for being able to leverage your version control system as your source of truth, using GitOps methodologies for triggering those workflows and deployments, having Kubernetes clusters, having those declaratively defined, having the additional supporting resources in the cluster, those software add-on packs, is defined in Terraform is big. So I can define, and we'll go through both the GUI way and the Terraform way, and then being able to provision those clusters in multiple clouds and having them identical in multiple clouds as well. Jesse, Neil, anything you would add?
Oh, absolutely. I was talking on mute. Sorry. Yeah. How about we tackle in? We'll show some Terraform, and then we'll use the GUI.
Yeah, sounds great.
All right. I think, should I stop sharing, Kyle, and you'll take over? I think so. There, Kyle.
I was also talking to you on mute.
Yes.
Yeah, give me 1 second. Let me share my screen. Can you see my screen?
Yep, I see it.
Excellent. So basically what we're going to do here is we're just going to hit merge on this merge request, and we'll look at a little bit of the code, and then we'll look at what's happening here. So you can see the pipeline already ran to be able to run my Terraform plan, which is being run in Terraform Cloud. And then we're clicking approve on this merge request. And if we go over to Spectro Cloud, which we'll walk through the GUI here in just a minute, but in just a second, what we should start to see is this the cluster start to spin up. We should start to see a couple of add-on packs created here. And you can see that just by clicking that merge request, I've got a cluster that's provisioning in AWS, and it's going to have 6 nodes, and the cluster profile is already fully defined for me. So now I just get to sit back and let that provision. So I'll pass it back over to Jesse to do a little bit of a walkthrough on the Palette GUI.
Okay, let me share my screen here. Tell me if you could see my screen.
We can.
Okay, so what you're looking at is Spectro Cloud Palette, and I'm going to log in here. This is available in both software as a service or as self-hosted, or available in air-gapped environments as well. Here I'm going to log in with a local account. And now we can also integrate this with any authentication platform that you have with OIDC or SAML-based authentication. So think Azure AD, Okta, Keycloak, OneLogin, you name it. As long as it has SAML or OIDC-based authentication capabilities, you can use your existing identity provider to log in and manage Palette, and log in and manage the Kubernetes clusters. So let me log in here. Okay, so when you first come into Spectro Cloud Palette in this environment, you get a good project overview here. And if we take kind of a peek back at the tenant admin view, you'll be able to dive down deep and see your infrastructure costs from both what your core components inside the cloud or on-premises costs for infrastructure, or what your licensing costs for Spectro Cloud Palette. So I won't do a deep dive into that right now, but I'll just show some of the features inside of Spectro Cloud Palette that you can also use to do this exact same lab demo that we're doing today. So one of the first things that we had to do is we separate by a project. Think of projects as like its own unique group, its own unique cryptography keys, its own SSH and cloud accounts. So in there you can separate and completely firewall off different departments or different organizations. Some managed services providers use it to separate their clients. Some enterprises use it to separate departments. So you have a number of different ways that you can slice that. But in this particular environment, we're using the default project. Now, we can manage both project settings, like I said, distinctly on their own, or also tenant settings. So a few things I'll show you in order for us to get set up inside Spectro Cloud Palette is where you can provide cloud accounts at your access. These cloud accounts can be both in the cloud and on premises that allow you to connect into the infrastructure and deploy Kubernetes nodes. So in this lab today, some of the, I think actually I should show our prerequisites here. Give me just a moment. I'll show them up in the screen in just a moment. But the first thing that you'll need is a cloud account, which I've already set up here. So if I scroll, if you notice here, I'm going to switch from the tenant settings to the project settings. And if I toggle back and forth, you see the tenant settings. They have the organization-wide settings that are held and could be and are propagated down to individual projects. And then we also have the default project settings, which are just limited in scope to that project. So here in this project, to make a long story short, I set up my AWS cloud account. So if you come in here and take a look at this, I've set up the access key and the secret access key, which was provided to me with Amazon. And you could do this with any cloud account. It doesn't have to be just Spectro. It doesn't have to be AWS. It can be Google. It can be Azure. It can be the managed services of any of those components. It can be VMware, MAS. We're seeing at the edge. So as long as you have those accounts that allow you to connect, you can connect in and build your infrastructure. So this is already deployed. So the next step, and you saw Kyle had just kicked off some Terraform script. Well, his Terraform script connected via the GUI and created this custom profile. I'll come back to that in just a moment. He did that one. And then he also did what's called an add-on profile. So he did all that with Terraform, which is the real way that administrators use Kubernetes. For demonstration purposes, though, the GUI is great to show what was going on behind that. So we'll do some of the things that Kyle just did, but in the GUI. So the first step I'll do, some of the components. Let me bring up that slide. Now's a good time to bring up that slide. Hold on. Can you see my slide?
We can.
Okay. So just quickly, I'm going to use Spectro Cloud Palette. I'm going to use Terraform. I'm going to use Kubernetes, and I'm going to use a version control system. In this demonstration, I'm using AWS credentials. You see some examples here. But I could use, as long as I have the appropriate credentials, I can deploy anywhere in appropriate permissions. Any questions so far? Okay, we'll dial into the demo here. Okay. So first, Kyle created the cluster profile, but let me just create a new one here. Do a GUI walkthrough of a profile. Now, this infrastructure here, you can create 3 different profiles. Full would be where you combine the applications and the core infrastructure. The core infrastructure is in order to deploy Spectro Cloud Palette Kubernetes clusters, you need right now 4 key components. You need to pick your operating system, you need to pick your Kubernetes distribution, and you need to pick a CNI and your CSI. So we'll do that here. And then you can also, if you're, depending upon how you're deploying applications, you can use add-on packs inside the Spectro Cloud Palette to deploy those applications or whatever solutions that are currently in your toolchain. So here I'll do an infrastructure profile, much like Kyle did. We'll call this, we'll do some tagging here. Now I can choose any solution here. We support, as long as there's a CAPI provider, we can work with it. And we work with all of these solutions on the screen here. For this demonstration, I'll use Infrastructure as a Service, or EC2 from Amazon. Okay, so right out of the box of Spectro Cloud Palette, we have repos that you can use to maybe 50, 60 different possible configurations that you can use out of the box. These are operating systems, Kubernetes distributions, CNIs, CSIs, and applications that we constantly package and put together as new Kubernetes and new operating system versions and new distributions are released. We consider ourselves agnostic in terms of operating system within reason or a distribution or CNI or CSI. We really want you to be able to bring all of your different components or pieces, your Lego parts, your Tetris parts, put them together so that you can build a Kubernetes that meets your business requirements. So in this case, I'm going to choose Ubuntu 2204. I'm an administrator in this environment. So I'm more of the operations persona here. Through role-based access control, I've been permitted permissions to modify some of these things. We'd like to call these the nerd knobs here around here. As long as you have appropriate permissions to control, you can come in here and modify any of these nerd knobs. Okay, I'll choose Kubernetes version. Let's choose 1254. Here again, the nerd knobs are here. Here's just some of the locations that you can configure OIDC integration. If you want to use your Okta or your Azure AD account to both manage Palette, your email, and Kubernetes clusters, you can do that. Here I'll pick just any CNI. You have a number of different options that you can choose from. And then I'll check. I'll I'll take the CSI. Depending upon where your environment is, in this particular cloud, we have these options available. On premise, maybe you're using a NetApp or Portworx or some storage that requires a different CSI. So if you need a democratic CSI or Trident CSI or Portworx, we can, if we don't have that out of the box, we have documentation that you can create your own, or we can assist you. For this demonstration purposes, I'll choose EBS CSI. Again, you have those different configurations that are available to me. And now I have the 4 basic components required to deploy a Kubernetes cluster. I have my operating system. I have my Kubernetes distribution, CNI, and CSI. We also have a pre-validation flight check, so to speak, so that when you mix and match these different components, we can identify if they work together. So if they're, for example, if I try to deploy a version of, if I try to deploy a core package, say with a different operating system, and then I cycled through, it'll let me know, hey, you're trying to use an older version of Ubuntu, and this version of Kubernetes requires this version of Ubuntu. So you can see there's some great controls out of the box to keep make sure that your deployments are working. We'll switch that back to 2204. We'll confirm, and then we'll finish that configuration. So now I have a manual configuration. I can either use that to deploy, or I could just use the Terraform script that was just created by Kyle. So let's do that. I can just hit deploy from here. And now it is using, I'll just name the cluster. Let's call it US West 2. And then here are the different cloud accounts that I have the ability to access. They've either been propagated down from the tenant settings, where you set them at the tenant settings. Maybe many of you are familiar with folder permissions or organizational units in Active Directory, where you kind of cascade down those settings. When you set up an AWS cloud account in the tenant settings, that will cascade down and be available to the different projects. If you set up that cloud account just in that project, it's restricted to that project. So here right now you see a combination of what the administrators have allowed to be cascaded down to me that I can choose to pick, or the account that I created myself, which is this one right here. Okay, so now I have the Terraform GUI, even though I'm going to deploy, the Terraform cluster profile that Kyle created, and then I can create an add-on. He did have a demo add-on, so let's just add that. So now here I am in the GUI, able to configure and deploy using Terraform created profiles that Kyle provided me. So the collaboration is there. The guardrails, if Kyle if I was the developer and Kyle was the operations person who said, hey, you can only deploy Kubernetes clusters with this particular OIDC configuration or this particular operating system in these applications, or nothing at all, then I would have to consume that. So there's a lot of different ways to either make it opinionated, remove the opinionated nature of it, continue on with declarative. So there's many different ways to skin the cat, so to speak. So here I'll just make some final configurations just for our demo. I'll deploy this one. I believe I have room in US West 2, maybe US 1. Now, I've already created this key pair. I did that using, I could use that via the AWS CLI or the AWS GUI. Kyle, in his deployment, he did everything via Terraform, so he didn't have to touch the GUI. Okay, so now through that cloud account, through Cluster API, I'm able to configure and manipulate resources in AWS right from the Spectro Cloud palette. So I'll come down here, I'll choose my instance type. Let's say I choose T3 large. And for redundancy purposes, I want 3 HA nodes. I want to roll them across different availability zones or fault-tolerant domains if you're inside of a local on-prem solution. And then we can configure the worker pool. Earlier you saw me had a chance, I could have picked managed Kubernetes solutions like EKS or AKS. Well, when you do that, they'll provide you their own control. It's probably elementary for some of you, but you'll have your own control plane nodes that are deployed by the managed Kubernetes provider. So you can't really configure and deploy in there. So a lot of people like the control plane nodes to be inside of infrastructure as a service, like I'm doing in EC2, because they have access to that. And then, of course, both solutions have worker nodes that you can configure. And maybe for the control plane, I need a smaller device, T3 large, and for the worker nodes, maybe they're a little bit beefier. Now, maybe I don't know that. Maybe I'm just some dumb kid out of the block, and I don't know. So Palette will provide some safe and guardrails that will allow you to understand, hey, kid, you're trying to deploy clusters with resources that are going to constrain your application. So we know what those applications need, so we recommend you make a change. In this case, it identifies that the worker nodes are don't have enough CPU cores. So I could just go back, take a look at my node configuration. Perhaps I change it. Maybe I go to a T3A 2x large, and maybe I want 2 nodes. Then I'll go. Maybe I want to deploy virtual clusters so that I can use this infrastructure that I have here for my developers that don't want to spin up Kubernetes. We'll get into that in a minute, but want to spin up and test their application. So now when I do the flight check, now it knows that, oh, okay, you do have the appropriate resources. So we'll finish that configuration there. Any questions so far? All right. Now one of the key components that we have is day 2 operations. So, Terraform's great for setting up infrastructure, deploying it out there, getting it spun up, and then what? Yeah, maybe you don't care. Some people don't care. They want to purposely allow drift. Well, one of the things that you use Kubernetes for is the power of declarative infrastructure. So I can say, hey, if the architect like me builds and designs maybe a 1-story ranch house, green, two-car garage detached, green Chevy truck in the driveway. That's my blueprint. That's my blueprint for the best possible life. And I roll that out and I deploy that through Spectro Cloud Palette. Now, if somebody comes along, tries to do an addition, paint the house red, change the truck to a Ford, within 2 minutes, we'll have reconciliation loops from Palette that will go out there and put it back in the place that the desired state for you to have. Now, if you want to allow drift, you can do that through application deployment through Spectro Cloud Palette. Use your kube, log in via kubectl or deploy your own Helm charts as you need it. Use your own application tools. But if you deploy it with Palette, you have the power of declarative technology where loops will roll that back. Okay, so let's talk about day 2 operations. So now, great, Terraform worked with Spectro Cloud Palette to deploy the cluster. What happens if I want to make some significant changes? So here I have a cluster called USE2-EC2. As you see, I have I have an infrastructure profile, SC, AWSTF copy, and an add-on profile. Now this cluster's up and running. Let's say it's been up and running for a couple of years, and somebody comes in and said, "Oh no, we need to make some changes." Okay, yeah, you need to update your operating system. You need to deploy a new version. It could be any number of things. So we could just come into these here, back to the profile. So let's take a look at SC AWS copy. You can see that I have now deployed this and it's in use, this blueprint, cluster profile, we call it around here a blueprint. That blueprint is now deployed into 2 clusters that are listed here. Now what happens if I want to change it? Say change the Kubernetes version down to 1256. Well, when I come up and I see these changes, I'll have some information. Oh, well, are you sure you want to make that change? This version of code use these parameters in the old version. If I had, for example, configured OIDC here, and then I tried to switch these versions, it would identify, say, hey, these changes you're making in red will be removed. These changes that you're making in green will be removed or will be added. And the changes in yellow are being modified. So then you have the ability to approve those changes if you're not, or you can say, hey, no way, there's no way that I'll do that. Alternatively, you can say, hey, there's 2 clusters that are in production. I don't want to mess around with them. Let me create a new test version. And we'll call that version 1.0.1, for example. Now the new cluster profile, it's giving a message, new cluster profile has been created. Now, as you see, there's no in-use clusters. And we have still back on the old profile with the original version 1 has the 2 clusters. So I can work here independently, get this all configured exactly how I want, and then I could make those changes. So alternatively, I can make it on a live profile, which is here. I'll show you an example. In this case, here was a cluster that I had where I made a change to the profile, and it told me the updates are available. Same screen I saw earlier. When I hit confirm updates here, it'll go out and make those changes on the cluster. So we'll sit and watch that happen here for a minute. Actually, Kyle, maybe now's a good time while we watch these changes roll out for you to talk a little bit about app mode, or maybe I should share a slide to set that up. How do you want to do the next?
Yeah, would love to have you set that up via slide. We're gonna probably wait just another couple minutes until that cluster is done provisioning, and then we'll fire off another Terraform run that'll set up a virtual cluster and some app profiles and do an app deployment.
Sounds good. Let me share here. Okay, there it is. Okay. Okay. So earlier we talked about some challenges. So while we let those clusters bake and build, and the Terraform clusters, I saw that was almost done. That Kyle had already started off, but we haven't. We have 2 actually. Earlier we talked about 2 different personas. We talked about that cluster admin, the operations guy, and then we talked about the developer. Well, one of the challenges that we see, a lot of developers are spending a lot of time deploying and managing Kubernetes infrastructure. Their bosses know that it needs to happen, and they need to spend their time on there. And ideally, they'd be just spending time with their apps and not deploying Kubernetes infrastructure, not understanding which are we using RKE2? Are we using managed Kubernetes? Are we using on-prem? So they would just all they really care about is, hey, can I quickly test my application? Think the inner loop. These concepts that we're talking about right now, they're really heavily focused on that inner loop that we talked about earlier. So in order to meet that need, with also trying to reduce sprawl. How many of you see a lot of seasoned veterans out here besides just me and Kyle? So many of you have seen physical server sprawl, virtual server sprawl, ESXi sprawl, and now we have container sprawl and Kubernetes sprawl. So one of the things that Spectro Cloud Palette does really well is that we are giving solutions to developers so that if you're not good at Kubernetes development, you can take advantage of existing deployments of Kubernetes and then spin up your own virtual instance, just like you did back in the day when you would spin up VMs. So in these next few environments, we're going to switch from cluster mode to application mode. And we'll show you how we can enable enable developers without having to learn 2 years of Kubernetes to deploy their apps quickly. And here I should say that in these packages that we're deploying out of the box, like we did with and we'll show this in a GUI in a moment, we have ability for you right out of the box to deploy some of these services, some common services that developers need so that you can get up and running. Okay. Without further ado, I think, Kyle, you want to demo?
Yeah, absolutely. Let me take over the screen here real quick. All right, so we've got another merge request that's set up with a few different changes that we've made from the code in the repository here. Go back to the clusters.
Are you sharing the screen? Sorry.
I am.
Okay, good.
Can you see my screen?
I can, yeah.
User error, sorry.
All right. So you can see this is the cluster that we created using Terraform just a little over 20 minutes ago. So all of the add-on profiles have been deployed. The infrastructure is there. The cluster is, all of the nodes are ready. It's just coming online to be healthy here. And we should see that update in just a second. And as soon as that's healthy, we'll go ahead and fire off this next Terraform run. In the meantime, I'll go ahead and show you a little bit about what this looks like in the repository and some of the files that we have in here. So as you can see, we have our modules folder here, and we have our clusters defined here. And if we go into variables, what you can see is that for demo purposes, we're just using some Boolean values to be able to flip these on or off. So right now, I have enabled AWS. That's what I changed this to true, which is what flipped over the cluster to be able to enable that configuration.
Kyle, we can't see your screen.
Thank you.
Yeah, it just stopped.
How's that?
Much better.
Okay, great. So right here, you can see we've got this enable AWS. We've changed this this value to true. We could do this for GCP, VMware. We have some other resources that are in here. A couple of these are virtual clusters and then the dev engine apps. So if we go back to the merge request, what has changed as a part of this merge request is we flipped those to true to keep this simple as a part of the demo. If we flip real quick over to Palette, you can see now that this cluster is healthy. Took a little over 20 minutes to be able to set all of this up. That was automatically generated as a part of that Terraform run. So we're going to go ahead and click merge on this. And what we should see here in just a second is that this pipeline is going to kick off. And then we're going to flip over into app mode. And when we go into app mode, this is more of the developer-centric view within Palette, where we can set up, very similar to a cluster profile, we can set up app profiles. I'm going to go ahead and let Jesse talk a little bit more about all of this. But as we see the Terraform apply start to run, what we should start to see is some additional app profiles start to pop up in here. And then we're also going to see some virtual clusters that are going to start kicking off. As you see, virtual cluster AWS.
Kyle, are you showing your palette? Oh, there it is. I see it now.
There we go.
Thank you.
So in app profiles here, we should start to see some of these app profiles start to spin up. So this is based off of the Google microservices demo in here. We should see a couple more that'll generate in here in just a minute. But this virtual cluster just got kicked off, and this is going to be a cluster inside of the cluster that we already provisioned just a few minutes ago. So as this starts to get healthy, I'll pass it back over to Jesse to cover more details of Palette app mode.
Yeah, let me share my screen here just a moment. Always the trick. Right here, share. Should be able to see my screen?
Yep, I can see that. It's the project overview, right?
Yep. Okay. So here I am in a cluster mode. You see I have all these bells and whistles over here. And here is app mode. And here's Spectro Cloud's attempt to try and help those teams that are complaining about learning Kubernetes for 2 years and 2 months. So that they can just know that there's underlying infrastructure. So Kyle, you deployed here, I believe, a virtual cluster, still provisioning virtual cluster AWS. You could see that information in here. You could see the usage and costs, the workloads once that spins up. And then you can notice virtual cluster AWS. If we switch back to the cluster settings, to cluster mode, we'll take a look at, we also have a listing of the the real clusters and the virtual clusters and the edge hosts here. We don't currently have any edge hosts as part of this demo, something we'll look out for in future webinars. But here's the virtual cluster that's spinning up and also one that's up and running. If we take a look at the clusters that are underlying from the the cluster mode, if we click on here, we can take a look at the different details and events. Have we backed it up? You know, what information is going on as that spins up? Cluster groups, that's a key component here. So in order for Kyle to deploy these virtual clusters, he had to first create a cluster group. Cluster group, simply described as underlying hosts and infrastructure that you can use with the existing Kubernetes deployed, CNI, CSIs, all that deployed, that virtual clusters will sit on top of it. So think ESXi node and a virtual machine. The cluster groups are ESXi node or group, and then the virtual cluster is a virtual machine sitting on top of that. And you can scroll inside and take a different and to look at different details. Okay, what's going on the underlying cluster? You can see Kyle at the beginning of our demo spun up via Terraform, a highly available a Kubernetes solution. Let's bring that up here. Okay, so now we can see the cluster is in a status of healthy. There's a few final errors and normal logging of any errors in the last 5 minutes, but in the next 5 minutes, as those errors fall off, there'll be no errors at all. The cluster will be running and healthy. You can see any details here. You can come in and maybe if you've deployed an application, you can come in and log into your application. You have helpful links that you can take a look at. Usage and costs. You know, we talked earlier, you know, about costs. The Spectro Cloud Palette, you can identify some of your core infrastructure costs like CPU, RAM, disk space, and you can also identify the licensing costs from Spectro Cloud Palette. So, you know, we spun this up just a few minutes ago. Here are the different, you can sort by namespaces. Perhaps your organization has a chargeback and they need to charge for the applications that are in use. So if you have 75 different namespaces and 75 different applications on your cluster, you can just sort by, okay, I just want to see what's the usage of these key services. And accordingly, you know, identify and report on costs for those namespaces or those projects. Here you can see the different profile. If we wanted, if there was a new version, we could come in and test that out. I could immediately switch this to 1.10 and it'll start deploying that cluster. As a cluster administrator, I have that capability. If, for example, I wanted to come in and update Spectro Cloud TF cluster, let's just look at you would just identify the profile, come in and make that change. Okay, switching back over to, I'm just taking a look at time here.
Yeah, it looks like a couple of things have happened here. So if we go back to apps now, we've got a couple of demos that have been deployed via the Terraform on a couple of different clusters there. If you go under virtual clusters, you'll see that virtual cluster is already spun up. If you remember, it took about 20 minutes for the AWS cluster to be able to provision. These virtual clusters, because they provision inside of a namespace, inside of an actual cluster, means that they come up much faster. So we can use these as a part of like our CI/CD pipelines for being able to create development workspaces for individuals, so we can provide them with full clusters as opposed to just namespace for that abstraction. If you go under apps for me and take a look at, or I'm sorry, app profiles, and you take a look at that online boutique one, what you can see here is that we've got the various layers of the application, the microservices, so that we can see those layers and how they're working together in for the application deployment itself. We can create from those services that Jesse had mentioned before, different, you know, we can have our database layer, we can have our front end container, we can have multiple layers that we can see and visualize as part of our application deployment process. And if we go under virtual clusters, and if you'll go under the second cluster there, that's the Beehive group.
Kyle, just while you're there, we've got a question in chat that I think is pretty relevant to what we're going through right now. Jeff was asking if we could see the Terraform project and how you've implemented feature flags for different clouds. Is that something you could show us?
Yeah, I don't know that we're going to have the full time for being able to go through the Terraform project today. As part of our takeaways, we really would love to be able to follow up with individuals to be able to dive deep into the Terraform project and the repositories that we have available.
Okay, great. I'll get with Jeff and we can see if we want to just do that one-on-one. Thanks.
Okay. And then Jesse, if I could have you real quick go back to that virtual cluster that we were looking at before.
Yep.
The second one there.
This one, Abidallah?
Yep. And then under apps, if you could click on online boutique demo. And then port 80 there. Looks like we should be able to.
I'll just point that out here. Another cool thing is as we deploy, you can identify what's the status of your app or layer. So here you see what's green and what it's working on. So we'll just go ahead and take a look at that front end and something has failed.
The point here being that we do have the ability to punch directly out to the container in the app that's deploying. It looks like it's not finished deploying quite yet.
Yeah, a little bit of work ahead of it. Yep.
Yeah.
We'll come back. It'll be something interesting to show in just a moment here. But it's the same concept that we saw earlier. If I switch over here to the cluster via the cluster that Kyle created, you saw how I was able to log into Grafana or the dashboard. So whatever services that you have deployed, you're able to log in and take a look. Although I don't know Kyle's username and password, if I did have it, I'd be able to log in here. And all of that stuff too is also configured. You know, we should talk about that. You know, good secret management and practice here. Kyle, you know, a lot of my demos, you know, a lot of us have learned the hard way about having an insecure password or a secret inside of a Git repo. Can you kind of talk about that, Neil?
Yeah, absolutely. A couple of different ways that we implement secrets. For this demo and our purposes here, we're using the variables in Terraform Cloud for being able to have all of those sensitive Terraform variables that are saved, being able to be passed directly into Terraform. We could also have saved them as a part of Vault or as a secret inside of your CI/CD pipeline itself. So we're using Terraform Cloud in this case, and I can show you just really briefly.
Mm-hmm.
Let's go here. So you can see this is the Terraform Cloud environment that was picking up the changes here. We can see that this is still applying, which is part of that application deployment that's not quite finished up. But under variables in this Terraform Cloud environment, we have the secrets saved for both the cloud environments and also that Grafana Prometheus secret that was you were showing there.
Good. Time check here. Neil, did you have any questions or anything?
Yeah, we had some other questions pop up. One of them in particular, just while we're talking about Terraform, was around managing state files and work spaces. So a lot of those kind of Terraform constructs. But how do we incorporate those when we're dealing with something like a GitOps approach to Kubernetes?
Yeah, I can take that one. So in this case, again, we're leveraging Terraform Cloud. So the state files are managed inside of Terraform Cloud. They're encrypted at rest and in transit as a part of that. Otherwise, we would need to explicitly plan for those state files and where they would end up living. Like if we had this set up using Terraform open source and a CI/CD pipeline as an example, we would have to push those into an S3 bucket or some other cloud-based storage that we would have to have that encryption process enabled manually, considered manually, both for the state files as they get pushed into the bucket, and also to make sure that they're encrypted in the cloud provider itself. In this case, Terraform Cloud's handling that for us.
Great. And we actually have another question from the chat here. It was just kind of a quick question about how we actually get from what we're showing today to interacting with the cluster via like kubectl.
Yeah, great question. Let me bring that up real quick. Give me just a sec. So you'll have the kubeconfig file here, and so you can just download that and access it. Let's take a quick peek at this config file that Kyle has here.
I'm not sure we can see your screen.
Thank you for telling me that. Hold on. Share. Screen 2. You see my screen?
Yep, that's great now.
Okay, so right here below where the services are is the kubeconfig file. So for this particular one, I'll just download that so we can open it. Bear with me. So on my screen is an eye chart. Hopefully you can all see that. In this particular config, Kyle could send this around. Kyle could send this to a white hacker or a black hacker and be secure, if you ask me. Because what's in here is he's configured his OIDC. So the hacker can do whatever he wants with this file, but he's not getting in to Kyle's identity provider. So if we didn't have OIDC authentic integration in this environment right here, this kubeconfig file will be wide open. So just wanted to highlight here's you can download the kubeconfig file and connect in. And 2, this is a super secure connection because we have OIDC enabled. Hopefully that answers your question.
Thanks, Jesse. I think it definitely does. We had another question about how to back this up in general. So, if beyond simply like, Spectro Cloud, but the whole GitOps infrastructure as well as Spectro Cloud that we've shown today, what would a backup strategy for this look like?
Well, I can speak specifically to the backup strategy for Spectro Cloud Palette. We found a lot of our customers, as they're rolling out and deploying it, maybe they have to go ask for Commvault or Veeam backups. So to kind of try and help them right out of the box, we have enabled Valero and Rustic. So immediately when you install Spectro Cloud Palette via SaaS, via self-hosted, or via air-gapped, you'll have access to that.
On the Terraform side, I would say, infrastructure as code best practices, being able to make sure that things are in Git, that Git is highly available, and that you have local copies and backups and clones.
Me, I'm a big backup. I love Commvault, Veeam, no particular order, maybe Commvault. But Veeam guys are great too, so there's a ton of different solutions that you can back up. Spectro Cloud Palette wanted to make sure that you had something out of the box from day one.
All right, I think that's all the questions we had. Thanks, guys.
Okay, let me just a few slides to finish up. One slide, maybe. Here on my screen, just displaying some ways you can learn more information. Kyle, Neil, and I are going to work on a follow-up blog here. So if you have any ideas for a follow-up blog for this presentation, please send it, and we'll make that happen. And we really want to encourage you to take a look at these 3 websites, and also to reach out and contact us. Here's our contact information. We really would love to dive into you deeper. You have the ability to do your own deployment. You can just go to our spectrocloud.com and do a free trial. But my team are able to assist you as well. So we really want to thank you all for coming out here and spending an hour with us today. Some topics we're really excited about. We hope this was helpful to you. And we have 2 minutes left. We'll turn it over to question and answer if you have any. Anything, Neil?
Yeah, we actually we had one just come in at the last minute there. Is this safe to integrate IAC pipeline with CI/CD pipeline? So a question about integrating an infrastructure as code pipeline with a deployment pipeline. Kyle, do you want to take that one?
Sure, I would say having infrastructure and applications version tested together is, I think, an ideal. We're not integrating necessarily, like we're using Terraform Cloud in this case for being able to handle like the CD portion of your infrastructure. We're using tests to be able to make sure that you have a good Terraform plan, and that the actual deployments of the clusters. When we get into the actual application deployment processes, preference there is going to be a CD type system where we're going to use CI and CD together to be able to handle the application deployments into the clusters themselves. So I wouldn't say in this demo or example we're necessarily integrating, but they're definitely, they should be parallel, and they should be working together, and we should be leveraging GitOps patterns, the patterns that application developers are already using for that self-service process that in infrastructure, with infrastructure as code and GitOps-based patterns.
I like that. That's true. Yeah, that's one thing I would leave too. I like the one Terraform is law. I'm a big fan and believer of Terraform right now, and I think you all should be too. So I would definitely take a look at some of these things that we talked about today, especially Terraform, especially Digital Velocity team at CDW too. We're just great at wrapping it all together. And please reach out to me, Kyle, and Neil anytime. Kyle and Neil, I'll turn it over to you to say goodbye and give everybody their day back.
Yeah, thank you, Jesse, and thank you to the entire Spectro Cloud team. Really appreciate the collaboration, partnership, and for having us here today to kind of talk about some of the things that we're doing over at CDW Digital Velocity.
Absolutely. Thanks, everyone.
Thanks, everyone. Have a great day.